Okay, last one on this test, and I'll try to get some data on this test for you too. But I'm going to show this is continuous at x equals 0, and really in class we talked about this saying, hey, can I just plug in 0 for each of these and show that they connect each other? And informally, yeah, that's good enough because we know that each of these are continuous, and so if they're both continuous and they both meet at 0, if one's continuous and this is continuous and they both meet at 0, then the whole thing is continuous. We know that, but as I looked at the rubric for grading this, they want you to actually show by the definition of continuity that this is continuous, okay, and that this is continuous, not just to assume that. So we actually have to use a definition of continuity. So let me write that down in my cool purple marker. Okay, so to do that, remember f is continuous at x equal a if the limit as x approaches a from the left of f of x equals the limit as x approaches a from the right of f of x equals f of a. Okay, that's what we have to show. Okay, so let's do that for a. The limit as x approaches 0 from the left, so that's the top function of 1 minus 2 sine of x. So I guess what I said earlier was not exactly accurate. We're not showing that this is continuous. We're showing this function is continuous at the point 0 by using the definition. So as it approaches 0 from the left, I plug 0 in for sine, and I get 1 minus 2 sine of 0, and that gives me, the sine of 0 is 0, so that gives me 1. The limit as x approaches 0 from the right of e to the negative 4x is e to the negative 4 times 0, which is 1. And therefore, these two combined, what is f of 0 equal to? F of 0 is equal to 1. Thus, the limit as x approaches 0 of f of x is equal to f of 0. So f is continuous at x equals 0. Okay, it is what we really did just plug it in. We're doing what I said you need to do. We're just writing out the definition to show using the definition of continuity at x equals 0. Okay, b. For x not equal to 0, write f prime as a piecewise defined function. Find the value for which f prime is equal to negative 3. So we get f prime of x. So we got the derivative of the top is negative 2 cosine of x for x less than or equal to 0. Oops. Does that work if it's equal to 0? Okay, let's do that. And negative 4 e to the negative 4x for x greater than 0. Okay. Find all values of x for which f prime of x equals negative 3. Well, we got negative 2 cosine of x. If that were equal to negative 3, then I'd have cosine of x equals 3/2. Well, that's never going to happen. The cosine of x, the biggest it is 1, so it's never going to be negative 1/2, so that can't happen. But I could I have this, negative 4 e to the negative 4x equaling negative 3? Well, that'd be e to the negative 4x equaling 3/4, which means, how do I solve that? That means write it as a logarithm. That means natural log of 3/4 equals negative 4x, which means x equals negative 1/4 natural log of 3/4. Okay, so f prime of negative 3, f prime of x equals negative 3 when x equals this guy, negative 1/4 natural log of 3/4. Wow, kind of yuck. Okay, C. Find the average value of f on the interval negative 1 to 1. So I know this is continuous, so it's not jumping anywhere, so I can go ahead and just use the normal definition of average value. And so that's going to be 1 over b minus a. So it's, minus a integral from a to b f of x dx. That's going to be 1 over 1 minus negative 1 integral negative 1 to 1 f of x dx. Now the problem that I have here is that I've got two different functions, so I'm going to have to rewrite this as 1 over, that's a half, the integral from negative 1 to 0. So from negative 1 to 0, which function am I working with? X less than 0, 1 minus 2 sine of x. Plus 1/2 the integral from 0 to 1 of e to the negative 4x, right? Okay, it's just a matter of doing these. So let's go ahead and just crunch this out real quick, and then we're done with this test. 1/2. So the integral of 1 is x. Integral of sine is negative cosine plus 2 cosine of x from negative 1 to 0 plus 1/2. This is u equal negative 4x. du is negative 4 dx. So I'm going to do this as integral of e to the u, put in a negative 4, take out a negative 1/4. I should have done it up here, negative 1/4, and then that's going to make this down here a negative 1 over 8 du, and that goes from 0 to negative 4. So then this becomes 1/2. If I plug in 0 in here, I get 0 plus 2 cosine of 0 minus, add my parentheses, plug in negative 1 plus 2 cosine of negative 1 minus 1/8, and this is e to the u from 0 to negative 4. So this becomes 1/2. Just got to be careful on these so you don't go too fast. Cosine of 0 is 1, so it's going to be 2. Cosine of negative 1, just leave it. So it'll be 2, and this will be plus 1 minus 2 cosine of negative 1. It's not a calculator problem, so we leave it there. And then this becomes minus 1/8 e to the negative 4 minus e to the 0. So we'll do a little simplifying. 2 plus 1 is 3, so it'll be 3/2 minus cosine of negative 1. And then this becomes minus 1 over 8 e to the 4th minus 1/8. And yeah, we can simplify this a little bit. 3/2 minus 1/8 times 4 times 4, so that's 12 minus 1 is, oh, this is a plus. Oops, sorry. 12 plus 1 is 13 over 8 minus cosine of negative 1 minus 1 over 8 e to the fourth. Easy to make a little sign mistake in there like that one right there. But there you have it. That should do all of that problem and all of this test. So we'll see you next time.